Okay, so when we do our decomposition, which we're going to get to soon, but there's a little bit of terminology and uh, tools that we need to kind of lay out first before we get into actually using the process. So it turns out there's a fact from algebra that says that every polynomial, uh, every polynomial uh, with real coefficients can be expressed in terms of either first degree factors, a product of first degree factors, or first degree factors and quadratic factors. The quadratic factors you'd be using are what are called irreducible quadratic factors, meaning that they're quadratics that have non-real solutions, right? The part in the square root, the discriminant, is less than 0. Okay, so it turns out that's a result from algebra. So we need only consider possibilities for our denominators are either linear factors, and so that's what we saw in our example where we had the two things that make up that denominator were just x plus 3 and x minus 2. They were linear factors. Okay. Well, the setup is for each linear factor that makes up your denominator, you're going to write that out as a fraction ax plus a over ax plus b. So some constant, some number over ax plus b. If you happen to have a repeated linear factor, so like maybe you had x plus 4 to the third was a factor of your denominator, well then you would actually have a fraction, if it was third power here, you'd have fraction for the first power, fraction for the second power, and then a fraction for the third power. So for each factor, each power, you'd have a fraction with, again, some constant over each of those different powers. Okay, that's the setup for that. If you have a quadratic factor, that means it's second degree, so we have to allow for the numerator to actually be first degree. Okay, and then we would write out the fraction like that. If we have a repeated quadratic factor, like if this thing was that stuff squared, then you'd have a fraction for the first power. You'd have ax plus b, and then you'd have like a cx plus d over that stuff squared. Right? Your second way of breaking that down. Okay. So that's a repeated quadratic factor. Now these choices are all made with a very important idea in mind, and that is the original fraction you're looking at. Okay, the original fraction that you're looking at. So when we take an algebraic fraction, when decomposing, p of x over q of x, right? A rational function, one polynomial over the other. We want the degree of the numerator to be less than the degree of the denominator. That's what's happening in all of our assumptions above with how we're going to break these different factors of the denominator up, is that the degree of the top is always smaller than the bottom. It's always smaller. That's why with quadratic we need to actually have an x and a constant term. But for all of our linear factors, that allows us to just have a constant in the numerator. Constant in the numerator. So that's what we want to have happen. Okay, if we don't have that, then we divide. All right, we're back to what we did in 8.1, where we introduced that idea of polynomial long division. Right, if the degree of the numerator is either the same size as or bigger than the denominator, then we do polynomial long division until we get down to the situation where we have the denominator having degree bigger than the numerator. Okay, and then we're ready to use the process. So that's an underlying assumption on every one of these results, how they're set up, is they're making the assumption that the denominator is bigger degree than the numerator. Okay. And there's different ways to do decomposition. We choose the way that we choose, the approach that we're going to be choosing, because of ease of integration, right? We use this setup like this with all the different powers, successive powers for a repeated factor, because those things are all easy to integrate, right? Those things are all going to be easy to integrate. And then we're stuck with the quadratic factor. We're stuck with the quadratic factor. If we're stuck with one, we're stuck with one. We prefer linear factors because those integrals are just easier. If we're stuck with the quadratic factor, we're stuck with the quadratic factor. Okay. We just have to make the best. Those are going to be more work. Certainly, no question at all. We'll just do our best. Right, so we'll be getting into some examples in the next upcoming videos where we actually see how this process works. See how this process works.